Hello. I know I'm a bit late to the party here, but I originally wasn't planning on doing this, but I saw a couple of videos of other people doing it, so I thought I'd give it a bash. Actually going through and attempting the 2025 Leaving Cert Higher Level Mathematics Paper 1. So, as I said, I reviewed the papers and I had to go at one question. Now, I know that kind of gives me a slight advantage, but I wouldn't think it's too much, so this is me actually going through it. So as always, 1, 2, 3, 4, 5, 6, and I was born the 12th, 34th in 2564. I know that's wrong, I'm just making stuff up. Center stamp, well, that's just me. Okay, now I have changed calculators since I last did these. I now have the FX83 GTCW. So, now what's the start time? Start time is 9:52. And let's go. So solve the following inequality for x and the reals. I'm just going to square both sides, so I'll get x squared take away 6x plus 9 is less than or equal to 144. So x squared take away 6x minus... Now I want to be careful with these because I know some people online have made mistakes in their addition. So now it's just the minus b formula. So what are we going to go here? So we get x equals 15, which makes sense. Well, these are the boundary points. So the boundary points are x equal to 15 and x equal to minus 9 as expected. But we want it less than or equal to 0, so I'm going to locate the points. There's our quadratic, and less than 0 is in here. So our interval is x is an element of the interval from minus 9 to 15 inclusive because we're talking about less than or equal to. Okay. Multiply out and simplify. Okay, 4x by 2x gives us an 8x squared. 4x by plus 5x is plus 20x root x. And take away 7, so minus 28x. Then minus 10 root x by 2 is minus 20x root x. Then minus 50x. And then plus 70 square root of x. So we have just the lone 8x squared. We have 20x root x's, minus 20x root x's. Okay, they disappear, so leaving us with a plus 70. Root x is the only thing with a square in it. And then minus 28, take away 50 is minus 78x. And I think that's okay. Okay. 2x minus 3 is a factor of that. Uses the information to find the three solutions to the following equation. Well, by that factor theorem, we already know that if 2x plus 3 is a root, then that implies x equals minus 3 over 2. Or sorry, I got these wrong way around. So if that's a factor, then that's a root, i.e. a solution. So I'll put that down as minus 2/3. So 2x plus 3 times... Now we want a 4x cubed, so the only way to get that is with a 2x squared. Plus bx. Now 3, the only way to get that is a plus 10 equals to 0. So when we expand this out, we have to kind of equate coefficients. So instead, I'm actually going to say this is identical to 4x cubed, take away 12x squared, take away 7x plus 30. So now what I'm going to do is I'm going to consider the ways I can get x. So it's either 3 by bx. So by equating the x's, we have 3bx. But then we also have 2x by 10, so plus 20x equals minus 7x. So 3b plus 20 is minus 7, so b equals 2 minus 9. Yep, that works. So 2x plus 3 times 2x squared, take 9x plus 10 equals to 0 because they're all equivalent. So now in solving that quadratic, we're just going to get something a bit nicer here, I would think. Okay, so here, well, it's not asking, it's asking for solutions. So with this, we get x equals to 5 over 2. Or x equals to 2. So we have minus 2/3, 5 over 2, and 2. Okay, perfect. A function is defined below, find f dash. So as always, I like to rewrite the function. So 6 plus x squared plus sine of 4x. That implies the derivative of f is going to be 2x plus 4 cosine 4x. Then find the equation of the tangent to curve, given your answer in that form. Okay. So at x equal to 0, we'll have f dash of 0, 2 lots of 0 plus 4 cosine of 4 lots of 0. Cosine of 0 is 1, so our slope is 4. Then at f of 0 is 6 plus 0 plus sine of 4 lots of 0. Sine of 0 is 0, so that goes, and we get 6. So with m equals 4 and our point being 0, comma 6, we'll have y minus y1 equals m x minus x1. So y minus 6 is just 4x. So 4x minus y plus 6 equals 0 is our tangent. Okay, function g is defined between 0 and 4. Its graph shown on the diagram on the right. We've got 2 line segments state the range of values of x for which g dash of x is greater than 2. Well, greater than 2, this one here, that's a slope of 3. So x has to be greater than 3 because at 3, we can see it's a sharp point and derivatives at sharp points aren't defined. So when x is greater than 3, that's when our slope is greater than 2. For the value of g of 3, well, g of 3 is 1. So g of 1 equals, well, that's a slope of a third. So that's just going to be a third. Show your work on the graph. Well, I mean, that's roughly a third, I guess. Okay. And now draw g inverse. So this is effectively just reflecting the graph about the line y equal to x. So it's going to look something like that's going to get mapped to there. And then we're going to have, again, I'm kind of eyeballing this. So maybe something like that. It's probably really badly drawn in fairness, but something that kind of looks like a symmetrical kite. Okay, the function f of x is defined for x and the reals. Find an expression for f of x. Or it's not f of x, f dash of x. What am I doing? Do not need to simplify your answer. Okay, so chain rule. U equals 3x to the 5, take away 4. So du by dx is 15x to the 4. And then y equals u to the 28. So dy by du is 28u to the 27. So f dash of x, which we can equivalently write as dy by dx, but we want it as f of x. So f dash of x is dy by du times du by dx. So it's 28u to the 27 times 15x to the 4. So 28, 3x to the 5 minus 4 to the 27 times 15x to the 4. Now it says I do not need to simplify my answer, so long as my answer doesn't have any u's in it, then we're all okay. Now b, function g is defined where x is not 3.5. By finding g of x, show that this function has no local maximum or minimum. So I'm going to rewrite g of x as 3 times 2x minus 7 to the minus 1. So again, this is another chain rule question. So u equals 2x minus 7. So du by dx equals 2. Y equals u to the minus 1. So dy by du is minus u to the minus 2. So g dash of x equals 3 times minus 2 over 2x minus 7 squared, which is minus 6 over 2x minus 7 squared. Okay, now since g dash of x is never equal to 0, can therefore have no local maximum or minimum. QD, because it's us to show that. Okay, k is real, is a constant, and that's true. Uses to find the value of k. So the integral between 0 and k of e to the 5x dx equals 9. Please put spaces in there. Now that's going to imply that e to the 5x over 5 evaluated between 0 and k equals 9. So we'll have e to the 5k take away e to the 5 lots of 0 equals 45. Now that's going to go to 1. So e to the 5k is, adding that 1 over gives us 46. So once in the form natural log of a over b, so k is the natural log of 46 over 5. Okay, I'll just save that currently. So write the complex number in the form a plus bi. Well, we're just going to multiply top and bottom by the complex conjugate. So that's the 4 plus 5i on top and bottom. Now that's going to give us 16 plus 25, which is 41. And then we'll have 2 lots of 4s. Why does that keep happening? Okay, 2 lots of 4 is 8. 2 lots of 5i is 10i. 4 lots of 3i is 12i. And then 3i by 5i is minus 15. So that's minus 7 plus 22i over 41, which is minus 7 over 41 plus 22 over 41i, and I feel like I've done something wrong. How's that ever? K used in Moivre's theorem and the expression that to prove the following is true for any angle. Well, cosine of theta plus I sine of theta power of n equals cosine n theta plus I sine n theta with de Moivre's theorem. So that implies that cosine of 2 theta plus I sine of 2 theta equals cosine theta plus I sine of theta to be squared, which, just rewrite cos 2 theta plus I sine 2 theta is, the real parts will have cosine theta squared take away sine squared theta, and then plus I sine theta cosine theta plus cosine theta sine theta. So by equating the real parts, cosine of 2 theta equals cosine squared theta subtract sine squared theta. My laptop is charging as well, so I'm just going to unplug it so it gets charged enough for me to go through the rest of this. Okay, use de Moivre's theorem to find the two values of z for which z to the 6 equals negative 64i. Okay. So I'm going to convert this into polar form. So if we draw ourselves an axis, that's the real axis, that's the imaginary axis. Minus 64i is going to be down here. R is going to be 64. And our angle is going to be 270 degrees, which is 3 pi on 2. So that implies that z to the 6 is 64 times cosine of 3 pi on 2 plus 2n pi plus I sine of 3 pi on 2 plus 2n pi. So by using the general case of de Moivre's theorem, we know z is 64 to the 1/6 times cosine of, that's going to be 3 pi over 12, which is pi on 4, plus pi n over 3, plus I sine of pi on 4 plus pi n on 3. Now, considering it says two values, I don't actually need to check all that much. So let's check n equal to 0 and see what we get. So 64 cosine of pi over 4. Oh, sorry, 64 to the 1/6. I'll see if it's probably not a nice number. Oh, it's 2. Okay. So z is 2 times cosine of pi over 4. I should know these, but I don't. Is root 2 on 2 plus root 2 on 2i. So we first get root 2 plus root 2i. And then n equals 1. If it gives us a different answer, then we know that everything is very cyclic. So it's 2 times pi over 4 plus pi over 3, 7 pi on 12. So cosine of 7 pi on 12 is minus root 6 plus root 2 on 4. And then sine of 7 pi on 12 is plus root 6 plus root 2 over 4i. So that's equal to root 2 minus root 6 over 2 plus root 2 plus root 6 over 2i. And I don't need to check anymore because it says 2. So they are our answers. Oh, it's given us room here. So root 2 plus root 2i, and then root 2 minus root 6 over 2 plus root 2 plus root 6 over 2i. Okay, perfect. I'll just give another little save there. Okay. Question number 5. The function g is defined as follows. Write g in completed square form. So, let's see. I'm going to take a factor of 5 out. And we're left with x squared plus 4x take away 12 over 5. So that's 5 times x plus 2 squared. Now that's going to give us a 4. So what do we need to do to counteract it? So we want a minus 12 over 5. So we'll have 4 minus or plus our scaling factor equals minus 12 over 5. So it's minus 12 over 5, subtract 4, which is minus 32 over 5. Which we can multiply inwards as just 5 times x plus 2 squared take away 32. That's our answer. P is a positive constant. Use the laws of logs to write the expression that in the form c plus d log p, where c, d are real. Okay, so I'm just going to rewrite this as natural log of distributing the power winners e to the 15 times p to the 5. And then we know that log of AB is log A plus log B. So that's equal to log of e to the 15 plus log of p to the 5. Now log of e is 1, so it's just going to be 15 by bringing this to the front. Plus, again, same logic that goes to the front, so 5 natural log of p. Okay, now I've already done this question, so I have a rough idea of what the answers are. I don't actually have my sheet with me in which I did it. So one of the solutions to the pair of equations is on the y-axis. Well, if that's the case, 0y is a solution. So here, by noticing equation 1, 2 lots of 0 take away y equals 7. So firstly, y equals minus 7. And then equation 2, x squared minus 7 plus 2 lots of minus 7 squared equals to n. And, oh, I forgot what I did here. Oh yeah. Well, 0y is also a solution. So actually, if I simplify this a bit more, I get minus 7. Two lots of minus 7 squared is 91. So I'll have x squared plus 91 equals n. That's equation 3. And then 0y we can sub in as well. So we have 0 squared plus y plus 2y squared also equals to n as equation number 4. No, what am I doing? I've done this wrong, haven't I? Oh yeah, no, because 0 is there as well. What am I doing? I don't actually need x or y. Yep, so n is just 91. Wow, I completely forgot how to do the question, but yeah, there we go. Okay, question number 6. Right, down into descending powers of p, the first 3 terms of the binomial expansion. So we'll have 7 choose 7 times 2p to the 7 plus 7 choose 6 2p to the 6 times 3 to the 1 plus 7 choose 5 2p to the 5 times 3 squared. 7 choose 7 is 1. 2 to the 7 is 128p to the 7 plus 7 choose 6 is 7. So 7 times 2 to the 6 times 3 is 1344p to the 6 plus 7 choose 5. So 7 NCR 5 times 2 to the 5 times 3 squared is plus 6048p to the 5 plus da da da. So those are the first 3 terms. That's all we're asked for. Okay, h of x is a function of x, m, and r and constants. If it's exactly one solution, then our discriminant equals 0. So our discriminant equals 4r squared minus 4 by 6m by 54m. So if one solution, we're going to set this to be 0. So that's 16r squared, subtract 4 by 6 by 54 is 1296. M equals 0. M squared, sorry. So 16r squared equals 1296 m squared. So if we take the 16 over, we get r squared equals 81m squared. So that implies that r equals to 9m. Now, we can ignore any plus or minus business because that's just the answer they want. Okay, so the fact that r equals 9m for the value of this solution. So now we're going to solve h of x equal to 0. So 6m squared. So 6m x squared. 4 lots of 9, so minus 36m x. Plus 54m equals 0. Now, considering in this case that, are we assuming m is non-zero? Yeah, they are positive constants, so m is non-zero. So we're free to divide through by this m, and we're now just solving 6x squared to take away 36x plus 54 equals 0, which I presume, because it's a solution, that is just going to be the 1. And well, we can actually divide through everything by 6, and we'll just get x squared take away 6x plus 9. Okay, right. So that's x minus 3 squared equals 0. So x is 3. Okay, perfect. Okay, that's all of section A done. Start at 9:52. That's 10:15, so 20-ish minutes. Okay, not too bad. Right, section B, spiderwebs, spiders build webs. So this question. Okay. So A is the extra length. So Yeah, that's going to be, Jesus Christ. It's going to be 22 because the difference between these two is 22. So the difference between 66 and 37.8, that's 28.2. So the numbers A1, A2, A3 form an arithmetic sequence. Find an expression for that. Well, our first term is A. Oh, in N. Okay, so our first term is 15.8 and our common difference is going to be 22 minus 15.8. So 6.2. Yeah, that works out. So I had to let out a big sneeze there. Okay, so we're looking for the nth term. So Tn is 15.8 plus n minus 1 by the difference. So 6.2n minus 6.2. So in fact, an, because that's how they want it's expressed, is 6.2n, 15.8 minus 16.2. That's plus 9.6. Answer otherwise for the value of A100. So A100 is 6.2 by 100 plus 9.6. Which is 629.6. Now, they give units. No, it just says total length. Okay, so we can just leave it as that. Sn is the total length of silk. Use the formula to sum an arithmetic series to show that that is true. Okay, so Sn is n over 2 times 2 lots of the first term, which is 15.8, plus d, which is 6.2, times n minus 1. N over 2, now 2 lots of 15.8 is 31.6, if I can even write numbers properly, because there's no colon in there. 31.6 plus 6.2n minus 6.2. So we'll have 6.2n, and then 31.6 minus 6.2 is positive 25.4. So we'll have 3.1n squared plus 12.7n. Okay, so that works out okay. Stage K is the first stage for which the total length of silk is more than 10 meters in this model. Use an expression for Sn. Remember, the Sn gives the total length of silk in centimeters. Okay. Did it say that? Gives lengths in centimeters. Okay. I misread that then. So A100 is the total extra length, so that's centimeters. Ugh. Okay. So we'll be careful our units here. 10 meters is 1,000 centimeters. So we want 1,000 to be 3.1n squared plus 12.7n. Now it says k, so actually we'll use k instead of n. So that implies that 3.1k squared plus 12.7k minus 1,000 equals to 0, just shoving everything onto that right hand side there. Now, solving this, okay. Our first answer, k equals 16.02857434. And our second answer is minus 20. So that we can just immediately discount. So at stage 16.02, we're going to have a total length over 10 meters. So at k equals 17, we're going to have that total length more than 10 meters, because at stage 16 it's not quite there yet. So k is 17. In the second model, the web is made in laps. Diagram on the right shows the first lap of the web. Yep. O1, O2, O3 are the first three orbitals. The lengths form a geometric series. Find the length of O3. So our common ratio is 0.53 over 0.5. which is 1.06. So O3 is just R lots of O2, which is 1.06 times 0.53, which is 0.5618 centimeters. Okay, right, expression for n, the total length of the first n orbitals of the web. That's a geometric series when it mentions the word total. So Sn is A times, now r is greater than 1, so I'm going to write it as r to the n minus 1 over r minus 1. So, I mean, does it really want things simplified? I mean, I'll take the 0.5 over 1.06 minus 1 out the front as 25 over 3 times 1.06 to the n minus 1. Okay, there are exactly 18 orbitals in each lap. Find an expression in k for the total length of the first k laps. Okay, so I'll need to find when n is 18. So S18 is 25 over 3, 1.06 to the 18 minus 1. Which is 15.45 equals 1 lap. So that implies that 15.45 k equals k laps. Oh no, that's not going to work. You can't just do it linearly because it goes up in a geometric series. Okay, I kind of jumped the gun a bit there. So each one's going to get longer by 1.06. So we're going to group things into 18s. So actually, if I replace this with, say, 18 orbitals equals 1 lap. So we can replace n with a k over 18. So it's 1.06 to the k over 18 minus 1 if we're now considering the laps instead of orbitals. Because then if we put 8, well, the first lap's not going to work. So actually it should be the other way around. It should be 18 to the power of 18k. Because that k equals 1, that works. K equals 2, that's, yeah, okay. Fixed it now. Screw that logic. It's just going to be that, 1.06 to the 18k. And that's the whole question. Oh, Lord. Get me out of here. Okay, Jacob buys a new kayak in a shop. The kayak is priced at $870. Price is reduced by 15% and a further reduction of 10. So let's consider the first reduction. That's 870 times 0.85. Which is 739.50. And then the second reduction will be on the reduced price, so 739.50 times 0.9, which is 665.55. Jacob has a paddle online. The paddle costs $95, and the exchange rate is that. The actual exchange rate is that. As a result, the paddle costs €1 2 cents more than Jacob thought it would. Okay, this is a funny one. Okay, so I'll convert the dollars into euros first. So if €1 is $1.183, then $1 is 1 divided by 1.183, which to the same degree of accuracy is 0.8453. So $95 at the original proposed exchange rate is 95 times 0.8453, which is 80.3035. Now, he paid an extra €2, so the extra charge will bring it up to 81.30 81.32. Okay. So that's how much he's actually paid. So now we need to find the actual exchange rate. This is quite puzzling here. I am going to have to sit and stare at this for a second. So $95 on the original. So he thinks it's 80.3035, but it's actually 81.32. So now we need to find 81.32 here. Or actually, on the old one, €1.02 is $1.2067. This should be fairly simple maths, but I'm not sure why I'm having an issue with it. And I am doing this in a run. I'm going to pin this and kind of just come back to it because it's a bit of an odd question. Oh. Great, now my screen's gone. I'm just going to wait for it to come back. So this doesn't go on the time. Oh, there we go. Okay. So hang on. I might have had a bit of a revelation in that time. I'm just still a bit confused with it. So I think my first stage of logic is right. So I don't think I need to reconvert it into that currency anymore. So we could say that if we just let the actual cost in euro be X, then the actual cost of it in that new ratio is just going to be 95 over X. And we want that equal to the total amount with the extra charge. So it's 95. Well, actually, no, I'm not sure I'm using X. I should be using D here. Because that's the variable in the question. So it's 95 over 81.32. It should give us something. $1.168. Okay, that makes a tiny bit of sense, but I'm not sure if it's correct. Oh, dearie me. Okay. Jacob takes part in a race, which involves kayaking and running. Yeah, this question. I gave a similar one to people that I tutor in a little mock exam, so this one should be fun. AS is 2 kilometers and AF is 8. SAF is the right angle, yep. Jacob kayaks an average speed of 6 kilometers an hour and runs at 12. If I'm allowed to take total to kayak from S to A and then run from A to F. Okay. So the total time is our distance over speed. So it's in kilometers per hour. So it'll be our distance in kilometers divided by his speed in kilometers per hour to get it in hours. So it'll be 2 over 6, so distance over speed plus distance over speed, and that gives us it in hours. So 2 over 6 plus 8 over 12 gives just 1 hour. Okay, that's convenient enough. Find out how it would take Jacob to kayak directly from S to F correct to the nearest minute. Okay, well that distance there is just going to be 2 squared plus 8 squared square rooted, which is 2 root 17. So his time is 2 root 17 over his kayaking speed, which is 6, which is 1.374368542 hours. If I take the remainder out, it's going to be 1 hour 22 minutes, I'm guessing. Okay, point B is on AF. Jacob's going to kayak from S to F and classic question. Find the expression in X for T, the total time and hours it'll take Jacob to get from S to B to F. Well, here that'll just be X squared plus 4 square rooted. So T is going to be distance over speed, so the X squared plus 4 square rooted over his speed in kayaking is 6, plus distance here, which is going to be 8 minus X, all divided by his running speed, which is 12, in units of hours. Which I'll actually just write this as T of X. Yeah, because it goes on to say T dash of X is that. So let me just rewrite the equation. So X squared. Oh my days, I hate Adobe Acrobat so much. So T of X is now my laptop's going lower again. My charger again. Because I just saw the screen dim, so that means it's low on battery, and I don't want it running out during this run. It's going to ruin my speedrun time. So unfortunately it's going to get a bit laggy again, guys, so just do bear with me. There we go. So x squared plus 4 over 6 plus 8 minus x over 12 equals to 0. So we want to just find its derivative. So here we'll just use the chain rule, which I'll do in the margin. So u equals x squared plus 4. So du by dx equals to 2x. Y equals u to the half. So I already know by this point that dy by du is 1 over 2 square roots of u. So that's going to be 2x over 6 times 2 root x squared plus 4 minus 1 over 12. They're going to cancel, and yeah, t dash of x. That is x over 6 root x squared plus 4 minus 1 over 12. There are no other values for of x in that interval for which t dash of x equals 0 apart from the answer. To part E, use this. We have to find. Okay, so it's not going to be that one because that has 2 turning points. This one also has 2 turning points. Now this one here doesn't appear to have a turning point, although it's probably down here. This one looks like it has a turning point there. So, representing t of x, okay. So yeah, if there's just one turning point, then if t is 0, then we're going to get something positive, and then as t grows larger, it's still going to remain positive. But then it's going to be a dip. So my... Let me try thinking this again. So as x increases, it's going to dip and then it's go up again, but it's going to go up at a fairly slow rate. Well, no, because it'd be nearly linear because you have a square root of a square. So I think it's d, just because there's one turning point and the growth after the turning point is close to linear. Oh, that's it. Okay, it didn't even ask us to find that minimum time. Okay, great. Just asked us to find an expression. Okay, Danny drives a car. The fuel consumption F of Danny's car is dependent on the car speed C. For one particular journey, F is given as that, where F is in litres per 10,000 kilometres, and C is in kilometres per hour, with C being between 40 and 120. So there's no difference between the fuel consumption when Danny's car is at 60 and 110. So F of 60, so we're just comparing F of 60 and F of 110. Where's my calculator? There it is. So 0.05 by 60 squared, take out 8.5 by 60, plus 800, which is 470 litres per 10,000 kilometres. And then when we replace all of them with 110, we'll get also 470. So equivalent. Find the expression for the FDC, the rate of fuel consumption with respect to speed. Okay, well this is fairly okay. If F of C 0.05 C squared take away 8.5 C plus 800, then that means that F dash of C is 0.1 C take away 8.5. I'll give it another quick little save here. Okay. During part of the journey, speed C is given as that, or T is the time in minutes, and C is in kilometers per hour. Ugh, okay. Use this in your answer part A to apply for another DFDC when T is 7. Okay. So C when T is 7 is 78 plus 9 natural log of 7 squared. Natural log 7 squared is 49, which one decimal place is 122.0. So DF, I should be writing that as DFDC, not F dash of C, I don't think, just to keep the notation of it clear. So that should be DFDC, DF of C, DC. So if DFDC 0.1C take away 8.5, but evaluated at C equals 122, 0.1 times 122 minus 8.5, which is 3.7 litres per 10,000 kilometers per kilometer per hour. That's just a ridiculous. There's probably some cancellation there with the fact that you could maybe turn L into a volume unit of, cubic kilometers or something, but that's ridiculous. Well, maybe the kilometers cancel or something, I don't know. Show the rate of change of the car's speed with respect to time is given by that. So dc dt. So if c is 78 plus 9 natural log of t squared, then it's more derivative. So u equals to t squared. So du dt is 2t. And y is natural log of u. So dy du is 1 over u. Implying that dc dt is 9 times 78 turns out not a constant, 2t over u, which is t squared, which turns into 18 over t. Perfect. Use your answers for part 3 and part 4 to find the rate of change of the car's fuel consumption respective time at the instant when t is 7 minutes. Your answer in litres per 10,000 kilometers per minute. Okay, so speed is in kilometers per hour, so we have to be a bit careful here. Rate of change of the car's fuel consumption. So we want df dt. So df dt is df by dc times dc by dt. df dc is 0.1 c take away 8.5 times dc dt, which is 18 over t. Okay, but df dc when t is 7 is 3.7. So this entire thing we know goes to 3.7, so it's just 3.7 times 18 over t. Then, again, I do have to be a bit careful here. Just because I know there's probably some unit trouble here. So at t equal to 7, if t here is... Yeah, t is a minute, so we're fine to sub that in. So at t equal to 7... screen's gone again. So df dc at t equal to 7, no, df dt at t equal to 7 is 3.7 times 18 over 7, which is 9.5 liters per 10,000 kilometers per minute, which I'm fairly certain I did incorrect because there's probably some unitary error going on. How's that ever? Over the first 8 seconds, oh yeah, the piecewise function, this is weird. So 8e to the power of, screwed up my calculator, 8e to the 0.4 by 1 and minus 8. So that's 3.9. I'll just double check my calculations correct. If I sub in 2, I'll get 9.8. That's fine. Then for 3, it's 18.6. What's that? Okay, that's fine. And then for the other two, we'll have negative answer squared plus 24 answer minus 48.4. I've already put 5 into there, so that's 46.6. And then at t equal to 6, we're going to get negative answer squared plus 24 answer, take away 48.4. That gives us 59.6. Hence draw the graph. Okay, so 0. 3.9 I'd say is about there. 9.8, so it's just shy of 10. Then 3 is 18.6. It's about there. 4 is 31.6. Oh, I've gone up way too high there. 18.6 is only there. No, it isn't. Gone again. 18.6. What am I doing? It's that there is 18.6. Jesus Christ. Wow, I'm literally not in it today. So 46.6 and 59.6. So 46.6. 59.6 is about there. 70.6 and 79.6. So 70.6, 79.6. So I presume that, well, we're going to have an exponential curve here. And then that's an inverse quadratic. So we're going to have something like that. Assuming it is continuous at this point. Oh, screen's gone again. Come on. Jesus Christ. Okay, use integration in that. Find the average speed of Danny's car and the interval 4 to 8. Give your answer in kilometers per hour, occur to one decimal place. Is that in... Are these in hours? That's time in seconds. Okay, but it's speed in kilometers per hour. Okay, so what's the average speed in kilometers per hour over that interval? Okay, so V bar is 1 over 8 minus 4 times the integral between 4 and 8 of negative t squared plus 24t minus 48.4 dt. Geez, my laptop's not liking Adobe Acrobat at the minute. So it's 1/4 times evaluate between 4 and 8 minus t cubed over 3 plus 12t squared minus 48.4t. So I'm just going to sub these in. So t equal to 8 minus answer cubed on 3 plus 12 answer squared minus 48. Minus answer cubed over 3 plus 12 answer squared minus 48.4 answer. Actually hating my calculator so much right now. So it's going to be 210.13. Well, it says to one decimal place, so 210.1 minus the same thing but replace it with 4s. So minus answer cubed 3 plus 12 answer squared minus 48.4 answer. We get another minus, so we get plus 22.9. So 210.1 plus 22.9 over 4 is 58.2 kilometers per hour to one decimal place. Again, I feel like I'm doing these wrong, but I just have to believe in myself at this point. I'm nearly done. Considering all the breaks that I've had to do, I'm probably going to get this under an hour in terms of writing time. Okay, the dots question. Right, so we'll just draw all the dots on the units. What am I doing? Not on the units. Janie Mac. We're just trying to form a square here. So that's there. Kind of just draw the outline here. So we're going to have one here, one there, one there, one there, one there. You know, all a distance of 1 unit away. Dots, the corner points have interior corners. All dots are 1 unit away from a point. Okay, so all 1 unit away from the previous point. I think that's fine. In pattern 2000, there are 4 points a distance of 2000 units from 0, 0, right on the coordinates of these 4 points. I'm just going to use some International Math Olympiad techniques. So all of them are just going to be the ones with the vertices. So there's minus 2, 0, there's 0, 2, there's 2, 0, and 0, minus 2. So they're all the ones at the edge. So we're going to have 0, 2000, 2000, 0, 0, minus 2000, and minus 2000, 0. Well, it's the smallest value of n for which the 0.44s in pattern n do not draw on your diagram for part A. Which one's going to have 4, 4 in it? Pattern. I'm instinctively thinking pattern 6 because in pattern 2 we have 1 for 1 1. There's 1 for 1 1. Here we have 1 for 2 2. So if pattern 2 has a 1 1, and pattern 4 has a 2 2, that means pattern 6 is going to have 3 3, and by that logic pattern 8 is going to have 4 4. So n equals 8. Qn is the proportion of points of integer coordinates where the mod of a and b is less than n. Okay, so write n in terms of t. Well, that's just t minus 1 over 2. So t minus 1 equals 2n. So n is t minus 1 over 2. Qn is given by that formula by substituting answer from di. Okay, so q of n is n plus 1 squared over 2n plus 1 squared, but n is t minus 1 over 2. So q of t minus 1 over 2 is t minus 1 over 2 plus 1 squared all over 2 times t minus 1 over 2 plus 1 squared. Okay, t minus 1 squared on 4 plus 2 times that, so it's just going to be t minus 1 plus 1 all over 2 times, they're going to cancel, and we just have t minus 1 squared plus twice the product, so 2 lots of t minus 1 plus 1. Okay, it's a lot of heavy algebra in this one. In fairness, I probably could have done this in a bit of a nicer method. First one squared plus twice the product plus the last thing squared, and then the first thing squared plus twice the product plus the last thing squared. I think if I multiply top and bottom by 4, there's probably going to be some cancellation here. So we'll have t minus 1 squared plus 4t minus 1 plus 4 over t minus 1, well, 4t minus 1 squared plus 8t minus 1 plus 4. So I really don't want to have to expand this out, but I think I have to. So we'll get t squared take away 2t plus 1 plus 4t minus 4 plus 4 all over 4t squared take away 8t plus 4 plus 8t minus 8 plus 4. So those units are all going to cancel. They're going to cancel, leaving us with the 4t squared in the bottom. And where am I getting that? Well, that just turns into plus 2t. So that's a t squared plus 2t plus 1 over 4t squared. Okay, find the value of q infinity, which is given by the limit as t approaches infinity. Well, the limit as t approaches infinity of t squared plus 2t plus 1 over 4t squared. Because this is a rational function of the two of the same power, we can just take the coefficients of the highest power and we just get a quarter. Okay, hn is the total number of dots in pattern n. Write down the value of h of 1, 4. When n is natural, hn plus 1 can always be found from hn using that formula. Using this fact, prove the identity in the grid below. Use proof by induction. Okay, so test for n equals 1. So h of 2 is h of 1 plus 2 lots of 1 plus 3. H of 1 we know is 4, so 4, 5, 6, 7, 8, 9. Is that true? In pattern 2 there's 9 dots. Yep, there are in fact 9. So true for n equals 1. Next, assume for n equals k in the integers that h of k plus 1 equals hk plus 2k plus 3. Let's see. Prove true for n equals k plus 1. So now we're going to test h of k plus 1 plus 1, which is k plus 2, equals h of k plus 1 plus 2 lots of k plus 1 plus 3. H of k plus 1 we know. So from step 2, we'll get h of k plus 2 equals h of k plus 2k plus 3 plus 2k plus 2 plus 3. So we'll have prove that h of n equals n plus 1 squared. Oh, I was misreading the thing, which is 2 plus 1 squared. I've misread the entire question. I got so confused there for a second. Okay, let's just erase all this and try again. Because I can't read. It's the last question. I'm feeling quite lethargic already. So we want that to equal k plus 1 squared. Okay, and then prove true for n equals k plus 1. So we're going to test the validity of h of k plus 2. We're going to guess that that's just equal to k plus 2 squared. So h of k plus 2 we also know we can use from our inductive step. It'll just be h of k plus 1 plus 2k plus 3, and we want to see if that's equal to k plus 2 squared. But h of k plus 1 we know is this as well. So h of k is 2k plus... And h of k plus 1 is h of k plus 2k plus 3, which is k plus 1 squared. Yeah. H of k plus 1 is k plus 1 squared as part of our inductive step. Okay, so we'll get k squared plus 2k plus 1 plus 2k plus 3, which is equal to k plus 2 squared. That's going to be k squared plus 4k plus 4. Okay, aha. K squared plus 4k plus 4 equals k plus 2 squared. And if we complete the square on the left-hand side, we're just going to get k plus 2 squared equals k plus 2 squared. So since true for n equals 1, and by assuming true for n equals k, proves true for n equals k plus 1, that implies the statement is true for all n in the naturals by induction. QED. Okay, that was a bit of a mess, but we got through it in the end. So that's the main thing. And yeah, that is the final question. So what is the time? Time is 11 o'clock bang on. Now I started this at 9:52. So that's 1 hour and 8 minutes. But considering I had to do a lot of stuff, it'd probably be closer to maybe 1 hour and 5 minutes. So what did I think? Yeah, quite difficult. As you can probably tell, I was stuck on a lot of the questions for a while. But yeah, it was a decent challenge. So if I've made mistakes, which I undoubtedly have, do just stick them in the comments. I'm trying to be as accurate as possible, but I'm only human. So yeah, thanks for watching.